Okay, so here's the third problem. So when I look at this problem, it says, it starts horizontal, it ends vertical, find the angular velocity. So anytime you see some kind of problem with dropping distances and velocities, it's going to be an energy problem. We could throw in springs as well, and then that would be still an energy problem. Okay, and so it says this thing is horizontal and released from rest. Find everything when it's in a vertical position. So this is a classic energy problem. Before is horizontal and after is vertical. And so I've drawn the before and the after. And so what it's going to involve is 1/2 mv squared, 1/2 I omega squared for kinetic energy, mgh, and it doesn't have it in this problem, but if there was a spring, 1/2 k delta x squared. And you do these four things before and after, okay? And so the mgh, you just have to pick a datum, or where you're going to count 0, where you're measuring h from. So what I decided was I was going to make the datum go through the bar when it's horizontal. And the reason I picked that, here's the center of gravity of the bar, there's the center of gravity of the wheel, and obviously those are going through the datum, so the mgh is 0. So it's released from rest, so it has no 1/2 mv squared, it has no 1/2 I omega squared, and because of the way I picked the datum, there is no mgh. Everything on the left is 0. I didn't have room to write this out as 6 things on the left and 6 things on the right, so I'm writing it in 2 lines. But it means like add all these things together and add all those things together. Okay, so afterwards, it has, I just wrote in 1/2 m of the bar, v of the bar squared, 1/2 I of the bar, omega of the bar squared, 1/2 m of the gear, and again these are at the center of mass, velocity squared, and 1/2 I of the gear, omega squared. Okay, we need to get the mgh, and so the bar weighs 3 pounds, that's mg, and we need to figure out if it's going up or down. So the center of gravity of the bar is in the middle there, and so that distance, it went down. The bar is 4.8 inches long, so the center of gravity is at 2.4 inches. It's nice, they want to notice at vertical, there's no cosines or anything. That bar, the center of gravity of the bar is down, so negative 2.4 inches, but I'm doing everything in feet, so I'm dividing by 12. Similarly, the center of gravity of the disc is at the end of the bar, because that's where it goes through the disc, and so that, or the gear. And so the distance to the gear center of gravity is the whole length of the bar, which is 4.8 inches. Again, it's going down, so negative. H is 4.8 inches, but I'm changing it to feet, divided by 12. Okay, so I'm going to write everything out. I'm going to put in the masses and the moments of inertia. So first of all, the mass is the weight divided by g, so 3 pounds over 32.2. And the I of the bar, that's the one I remembered, 1/12 mass times length squared. So it's 1/12, the mass is 3 pounds over 32.2, and the length, again, I'm doing everything in feet, is 4.8 inches divided by 12 feet and squared. That comes out to a really small number, 0.001242. Now, for the exam, you're going to be multiplying and dividing by these very small numbers. So I made sure that I had 4 significant figures. I could see 4 numbers in there. It's not the number of digits, it's how many numbers you see. So I see 1, 2, 4, 2, 4 numbers. Similarly, I for the gear, they gave you that radius of gyration was 1.2 inches. And so it's just mass times radius of gyration, 1.2 divided by 12, turn it into feet squared. And that again is a really tiny number. So I carried it out to where I could see 4 of those numbers, 1863. Point double naught, 1863. Okay, so I have the masses, I have the moment of inertias, and I just put them all in right here. So the left-hand side was all 0, the right-hand side 1/2 mass of the bar times v bar squared 1/2 I of the bar times omega bar squared 1/2 mass of the gear, I of the gear, etc. And then if you add up the MGHs, they come out to minus 2.4. Okay, and minus 0.6. Okay, so I put everything on the numbers on the left-hand side, the unknowns on the right-hand side. So you got 3 on the left-hand side, and look, you've got 4 unknowns: V bar, V gear, omega gear. But you only have one equation. Whenever you do energy, there's only the one equation. So we need to get rid of 3 of the variables somehow. And we will always do it via kinematics. Okay, so we know this bar is definitely spinning about this point here because it's pinned. You look at that picture, there's a gigantic pin right here at A. Okay. The gear is definitely spinning about the bottom because it's got teeth. That's how gears work. They make gears so they don't slip. Okay? So it's definitely 0 velocity right there. Okay, so knowing that, okay, here's omega of the bar. We know that this velocity here, the omega of the bar, the velocity of the bar at its center of mass is this distance, which is 2.4 inches. And again, I'm turning everything into feet times omega of the bar. And the gear happens to be attached to the end of the bar, the center of the gear. So that's the velocity of the gear. And this distance here is the length of the bar, which is 4.8 inches. Again, turning into feet divided by 12 times omega of the bar. So that comes out to nicely 0.4 omega bar. It's nice that he made the bar 4.8 inches long because that turns out to 0.4 feet because we're doing everything at feet. Okay, so we got rid of the velocity of the bar in terms of omega of the bar and the velocity of gear in terms of omega of the bar. Can we get rid of the omega of the gear in terms of omega of the bar? So now let's look at the gear. So the gear, the point that's not moving is the bottom because that's where the teeth are meshing. And so we know that the velocity of the gear, which we know is 0.4 omega b, is this distance, which is 2 inches, turned into feet, 2 over 12 times omega of the gear. So solving for the omega of the gear, that equals 6 v of the gear. But we know v of the gear is 0.4 omega b, so we get omega of the gear is 2.4 omega b. So now we have everything in terms of omega of the bar. So see, look at here. We've got the velocity of the bar is 0.2 omega b. The velocity of the gear is 0.4 omega b. And the omega of the gear is 2.4 omega b. And of course, the omega of the bar is the omega of the bar. So you put these things into that ugly equation there. And now you have one equation with one unknown, omega b squared. And if I did everything right, and this is why you have to have all these numbers now, because when you add them all up, I now have this to 4 numbers. Great. And so we got 3 equals 0.02276, and you divide that through and you get omega of the bar is 11.48 radians per second. It also asks what's omega of the gear. That's 2.4 omega of the bar. If I ask what's velocity of the bar, you go back up here and you see, oh, velocity of the bar is 0.2 omega b. What's the velocity of the gear? 0.4 omega b. Okay, so there you go. This is kind of an easy problem, but you just have to be careful about the masses and the units and the i's. Now, I want to show you what would happen if you did not keep enough figures. Okay, so if you said 3.0 equals 0.05 0.2 omega b squared plus, and then for some reason, let's say you kept this one to all its figures. And this one, let's say for some reason you rounded. And this one, you did that. Okay, I'm going to solve this, and let's see if you get close to the answer, which is supposed to be 11.48 radians per second. Okay, I'll be right back. Okay, and if you do that, you get 11.23 radians per second. So you notice it doesn't match in the third digit. And so it's because I replaced 466 with 5. And, 47 is close to 5, but it's definitely no good out to there. So wherever you start chopping off significant figures, that's how accurate your answer will be in the end. I'm not going to take points off on the exam. This is just something for you to know for your future career. If you want your final answer to be good to 3 significant figures, make sure you keep 3 significant figures, meaning you need to see 3 numbers in these tiny things in your calculations.